Hey guys, today we'll be learning how to add and subtract radicals. So let's start off by learning how to add radicals. So the example root 5 plus root 5. So a general rule when adding and subtracting radicals is that the number inside the radical has to be the same. So the number 5 is the same on for both radicals. And when you add and subtract, you don't add the numbers inside the radicals or subtract the numbers inside the radicals. So the number of root 5 stays the exact same for the answer. So what do you add? So you add the numbers outside the radicals. So when there's nothing outside the radicals, it's generally believed it is known that there's a 1 there. There is a 1 times root 5. So there is a 1 there. So 1 times root 5 equals root 5. So 1 plus 1 equals 2. So you just put a 2 there, and that's the answer. So root 5 plus root 5 equals 2 root 5. Let's look at another example. So root 2 plus root 2. Well, there's a 1 on the outside, and you don't add the numbers inside the radicals, and they're the exact same. So root 2 goes on the outside, and 1 plus 1 is 2. So the answer is 2 root 2. So going on to our third example, so 4 root 3 plus 7 root 3. Well, we can add these numbers because the number inside the radicals are the exact same. So 3 is the same as 3. So we can put 3 on the outside. And we can add these numbers. So 4 plus 7. So we add the numbers outside. So 4 plus 7 is 11. So the answer would be 11 root 3. Now that we learned how to add radicals, let's learn how to subtract them. Okay. So let's just draw kind of a space on the side. So let's say there's a number like 5 root 2 minus root 2. Same rule as the addition side. You do not subtract the numbers inside the radicals, and they have to be the same to perform the operation. So just as an example, you can't subtract something like 5 root 2 minus root 3. Because these numbers have to be the same. Great, so 5 root 2, so you put a root 2 on the answer side, and and there's a 1 here. There's the invisible 1. So 5 minus 1 is 4. So the answer would be 4 root 2. So going on to some further examples, since we kind of know the gist of adding and subtracting numbers, let's go on to some harder questions. So let's see. Okay. So root 20 plus root 5. Well, you're probably thinking that you can't add these numbers because they don't have the same number on the inside. Well, root 20 can be simplified further, but root 5 cannot because it's a prime number. So let's try simplifying this root 20. So 4 times 5 is 20, and then 2 times 2 is 4. Since there's a 2 over here, we group them in pairs of 2. 1, 2 gets eliminated, and the 2 that survives goes on the outside. And the 5 that is left alone goes inside the radical. So root 20 and 2 root 5 are the exact same thing. So let's rewrite this question as 2 root 5 plus root 5. Well, now we can add them because 5 is on both sides. Root 5 is on both sides. So we can put a root 5 on the outside, and then we can add 2 plus the invisible 1, which is 3 root 5. Great. So let's try a subtraction problem. here. So root 18 minus root 8. Both of them can be simplified further. So what we do is 9 times 2 equals 18. 3 times 3 equals 9. So 1, 3 gets eliminated. So 3 goes on the outside, and the 2 that's left alone comes on the inside. And simplifying root 8, so 2 times 4, and then 2 times 2. So group them by 2. 1, 2 goes on the outside, and the 2 that was left alone goes on the inside. Great. So now we can subtract them. Since the root 2 is on both sides, this operation can be fulfilled. So root 2 goes on the answer side. Another reminder, you do not perform addition and subtraction to the numbers inside the radicals. It's only the numbers outside the radicals. So 3 minus 2 is 1. So in your answer, when there's a 1 on the outside, you generally don't place the 1 on the outside. It's kind of known. It just turns invisible. But if you do put this, it is correct. But it's just more better if you use this method. Making the 1 invisible. So that's all for adding and subtracting radicals.